Over the last 2 units, we've introduced some very interesting concepts: electric force, electric field, electric potential energy, and electric potential. And they're all very closely related. These equations here are generated by point charges, and that's all we can use. And you'll notice that each one of them has a K, Coulomb's constant. We started with electric force, which is the force between two charges. This thing here is a vector. This is r hat. That has a magnitude of 1, and it's in a direction between the two charges. We then divided out a Q over here, and we came up with the electric field, which is a property of space and only depends on one charge. Then, using calculus, which we'll show you in APC, we derived potential energy from work. And we found out that that's K Q1 Q2 over R. Notice how we went from R squared to R. Using a similar technique, we divided out by Q again, and we came up with electric potential or voltage, which is a scalar field, again a property of space. To help you remember, as you go from left to right, what happens? You lose a Q. As you go from top to bottom, you lose an R in the denominator. And these are vectors, these are scalars. We also came up with this equation. We derived that in a couple different methods, but the electric field is negative the change in voltage per displacement. And that works for point charges and uniform electric fields. Then we talked about infinite planes, where we had two planes of charge separated by a distance d, and we came up with two very specific equations that are only used for uniform electric fields. Potential energy is minus QEd. E is constant, d is the distance between the planes, and then E is minus delta V over d.